You're watching the free version of SynthEyes Essentials. For projects and footage, head to BorisFX.com for the premium download. Hey, and welcome back to SynthEyes Essentials. In this class, I want to take you onto a deep dive into coordinate systems inside of SynthEyes. We already set up coordinate systems for all the shots we worked on so far, but never really explored what is going on under the hood. So what is a coordinate system? If we take a look at this kind of graph, which you probably remember from your math classes, the horizontal line is the x-axis and the vertical line is the y-axis. And any point we put down here is a coordinate inside this two-dimensional coordinate system. Now, a 2D coordinate system will not help very much when it comes to representing a 3D scene, so we need a third axis. Let's keep x for being the horizontal axis, but y will now be responsible to determine whether something is near or far. And z will be responsible for representing up and down in our scene. The point where all three axes intersect is called the origin point, and everything where z, our up and down axis, is 0, is considered the ground plane. Basically the floor of our virtual world, but it could as well be a tabletop or any other kind of surface. By the way, this is called a z-up coordinate system because z is specifying the axis going up and down, and it is used not only in SynthEyes, but also in Blender, Unreal, or 3D Studio Max. If you are already using software like Maya, Nuke, Flame, Cinema 4D, or Houdini, then a z-up coordinate system might be confusing to you. Those applications use a y-up coordinate system, so y is responsible for up and down, and z takes care of near and far. Fret not, you can easily change the orientation for your current scene here in the menu bar under Edit, Edit Scene Settings. I will stick with SynthEyes' default z-up coordinate system. Now that we established what a coordinate system is, let's tackle the next obvious question. Why should you care? Honestly, SynthEyes will not benefit from you providing a correct alignment to your scene. It only cares about the relationship between the various trackers and the camera. No, the coordinate system is there for your benefit and your convenience. Let's load up the shot for this class. It's shot at 24 frames per second and the sensor width is 17.3 mm. The chessboard should be a great example for a coordinate system, as the 8x8 square playing field is, for all intents and purposes, a small coordinate system. We are going to start the shot in a pretty familiar way, by auto-tracking it. I'm going to bump up the maximum tracker count to 500 and set the small blip size to 10 and the big blip size to 20. If we go to the trackers room, we can see that while we do have some stray trackers, this should solve pretty well. Before we do that, however, I want to add 5 additional manual trackers. That way I can not only place them where I actually need them, but also make sure that they are not touched by SynthEyes when we refine the shot. This will be important later on, as we want to compare 2 different ways of setting up our coordinate system. Our first tracker will be placed squarely in the middle of our chessboard, as this will later serve as the origin point of our scene. Using our new best friend, the corner tracking mode, I will lock the viewer by pressing 5 and track away by pressing and holding D. I will track on until the king obscures our target area and lock that tracker. Now, when placing the next tracker, think of the 3 axes we discussed earlier. We want to have a tracker that is conveniently located along the x-axis, so on the left or the right of that tracker. So I'm going to move 3 squares to the left and repeat the whole process. This tracker will hold up a little bit longer, but it is not really that important, as there are enough auto-trackers to do the heavy lifting. Last but not least, let's add a tracker on the y-axis. The corner between the queen, the king, and the 2 pawns is ideally located, even if only for a short amount of time. We are going to add 2 more trackers. I want to have 2 trackers directly on adjacent corners, because those will be a really good showcase on how to introduce real-world scaling to our scene. So we will track them in now, but they will really shine later on in the class. The first one needs a little bit of nudging when the light reflects off the surface, but apart from that, those two should be smooth sailing. Let's move over to the solver room and do our initial solve. Once our solve is done, let's take a quick look at the layout. On the top, we've got 3 familiar views, top, front, and left. And down on the left in each window, we do see a little widget informing us on which way which axis is pointing. So that is an additional help in getting your bearings. Also, note the color coding. The x-axis is always colored red, the y-axis always green, and the z-axis always blue. The error just above 3 is quite okay. By now we know the tools how to get such a solve across the finish line. But for now, I'm just going to get rid of this single tracker up here, as having such a far away tracker would make navigating the scene unnecessarily hard. So removing that single tracker alone dropped our error to 2.5. By the way, the SynthEyes solver is non-deterministic, so you will not necessarily come up with the exact same result as I did. Don't panic. As long as you've got those 5 manual trackers in place, you will be able to follow along easily. Our initial solve is, like so many we've already done, weirdly tilted. Let me just quickly show you why it is a really bad idea to not apply a proper coordinate system. I'm going to switch to the 3D room and create a cube on a single square of our chessboard as reference geometry. We know that our manual tracker 501 is in the center of the chessboard, so let's zoom in there, center our viewers, and create a cube. Already you can see that even though I clicked on tracker 501 in the top view when creating the cube, the shape doesn't show up anywhere near that tracker in the camera view. That is because SynthEyes will take the ground plane as a base when choosing the position of a primitive to be created. That is why it is located well below our point cloud. Translating it off the ground plane is pretty easy. The hard part begins when we try to rotate it into place. So eventually we got there, but let's think a little bit ahead here. You are most likely not placing just a single object into your scene. You will also not only have to navigate your scene inside of SynthEyes, but also in your CG or compositing application. And be kind and think of other people that will build upon your work. So let's explore how setting up the coordinate system correctly once will cut down the number of clicks to line up something as straightforward as a box from 30 clicks to 3. To do that, we will take a more detailed look at 2 techniques we already used, the *3 method and manual alignment. Let's delete that box and also save away our scene so that we've got this as a base once we want to explore the second method. Let's start with the *3 method and go to the coordinates room. Now it's time to shine for our manual trackers. We set up tracker 501 squarely in the middle with good reason, so let's click the *3 button. It turns blue and asks us for the origin point, so tracker 501 it is. Let's not click the next tracker right away, but let's instead have a look at the constraints list here. Tracker 501 shows up and is locked to x equals 0, y equals 0, and z equals 0. And that of course now means that tracker 501 is indeed at the origin point of our coordinate system. Also, notice the blue cross indicating that this tracker is now constrained. Don't be concerned about the forbiddingly high error value here. The constraints will be applied once we clicked all 3 required trackers. That is why right now there's such a big mismatch between where we are telling SynthEyes that this point is supposed to be and where it right now still resides. Next up, SynthEyes wants us to define left and right of our scene, or, as I explained earlier, our x-axis. This is showtime for tracker 502, so let's select it. Now tracker 502 shows up in the constraint points list as well, being constrained on all 3 axes as well as being on the same height and the same depth as tracker 501, but it is 20 units apart on the x-axis. 20 units of what? Well, SynthEyes is metric agnostic, so it basically is up to us to decide whether this means 20 centimeters, 20 feet, 20 miles, or 20 kilometers. For now, let's ignore the distance, but we will get back to that topic. Let's just acknowledge that this value of 20 tells SynthEyes that tracker 502 is definitely not in the same place on the x-axis as tracker 501. Last but not least, we need to define the planar orientation. So let's shuttle to a frame where we can see tracker 503 and select it. Once we do, SynthEyes will ask us if we want to apply the coordinate system. Clicking yes will bring us directly to the solver room and run a refinement of our scene. That looks much more navigatable than what we had before. In the point cloud, we can now clearly distinguish between the table, the couch, and we can even make out some trackers on the chess pieces. Let's move to the 3D room and see how that benefits us. When we create the box, we basically draw it along the ground plane. As that is sitting directly on our chessboard, we don't need to do any manual rotation and our box is sitting in there nicely. This becomes especially apparent when we move the box around the chessboard by just moving it in the top view. Imagine doing that without a proper alignment. We still have to deal with a high error value though. So in the solver room, I'll check Calculate Distortion and I'll also press Shift-C to run the Cleanup Trackers dialog. In this case, I will not select all trackers, as I want the Cleanup Trackers dialog to not touch my manual trackers in any way. This is something to be aware of. You can of course also perform something like the *3 method with auto trackers, but if you accidentally picked a high error one that is then deleted by the Cleanup Trackers dialog, you can seriously mess up your constraints. So choose wisely. But in our scenario, I want the cleanup just on the auto trackers, so I will select all options and press Fix. Once I refine, my point cloud and camera track adjust ever so slightly, the error value is getting much lower, but the box is staying where it is supposed to be. And that is because the constraints are forcing the solver to put those 3 trackers into the coordinates we defined. Hence, the box will always end up in that place. To prove this point even more, let's actually delete our solve. You can see in the top 3 views that there are neither solved points nor a camera path, and as the camera is leveled out, our geometry is totally out of place. But the yellow points indicate that constraints are still present. So watch what happens if we once again solve our scene. Magic! Everything is once again properly aligned. With the *3 method properly deconstructed, this is a good time to take a small break. Join me for the second part of this class, where we will talk all things manual alignment and distance constraints. See you there!